Alright guys, so today we're looking at section 6.3, which is contingency tables and conditional probability. A contingency table is a table that compares two variables. So in this table, we're looking at if a person has pierced ears, yes or no, and if they are male or female. So the way we read this table is there were 90 total males surveyed, and here there were 88 females, so there for a total of 178 total people surveyed. 103 people had pierced ears, 75 people did not have pierced ears, again for a total of 178. Alright, so we're going to let A be the male pierced ears, and males, and B be pierced ears. So when I look at the probability of A, I'm looking at the probability that the person was male. So the way we deal with contingency tables is we do male over the total. Okay, so male, there were 90 out of 178, and that's going to give me 0.51. I'm going to actually get my calculator to see what it actually is exactly. So it's 0.55, 0.505. So we round it to just two decimal places, so 0.51. And you could make that a percentage. I will take any of these. I will take that, or that. Any of those would be fine. Okay, next is the probability that the person has pierced ears. Probability pierced ears. So again, we're going to work this the way we did the last one. So we're going to do pierced out of the total. Okay, so how many people have pierced ears? 103 out of the 178. So 103 divided by 178. And we're going to make that 0.58 or 58%. All right. Now, remember this means and. Okay, so this one, the probability that they are male and pierced ears. Okay, so we need the male pierced ears. So we're going to do male and pierced ears over the total. So male pierced ears are 19 out of 178, and that's going to become 0.11, which is 11%. Okay. Next, this means or. Okay, so for or, we're going to do, where'd my other pen go? Okay, so we're going to do the probability that they are male or pierced ears. Now remember, if we're doing that, we have to do, with or, you have to do the additional. So you do male probability plus pierced ears probability. Then you have to subtract off the overlap. So anytime you have or, you have to subtract off the overlap. Okay, so we have 90 over 178 plus 103 over 178 minus 19 over 178, which gives me 174 over 178, which is 0.98 or 98%. That the person is male or has pierced ears. Okay, so you're counting all the pierced ear people, so the women with pierced ears and all the men. So that's how you get so many. Okay, conditional probability. Okay, let's look at that. The definition of conditional probability is the probability that one event happens given that another event is already known to have happened. Okay, so they're going to be written like this. The probability of B given that A has already happened. So we're going to write that down. This translates into the probability of B given that A has already happened. Sorry, I don't write very straight on these papers. Alright, so how do you calculate it? So you do the probability of A and B over the probability of A. Or, the way we can word that so it's not just with A's and B's, the probability of both divided by the probability of given. All right. Now, so using the previous example, we're going to do the probability of A and B over the probability of A. Okay, so this means male and pierced ears over probability that they're male. Okay, so probability of male and pierced ears is 19 over 178. And this pen's about to die. I shouldn't have used it. And the probability that they're male is 90 over 178. So this creates a funky fraction. So I want to come over here to the side and show you something. So remember in keep, change, flip, we learned this last unit. Those are going to cancel. So every single time you can just take that number over this number. So you don't have to put the total under both. Okay, so it'll cut you a little bit of a break. So that's 19 out of 90, which is 0.21, which is 21%. Okay. Now, this one says the probability of A given B. So this is probability of A and B over the probability of B. So this is going to be male and pierced ears over pierced ears. So male and pierced ears is 19. Pierced ears is 103. If you look up at your chart, which is 0.18, which is 18%. Okay. Now, we're going to create a chart and answer questions about it. All right. So a women's club has 80% of its members married. 30% of the married women are pro-choice, and 75% of the single women are pro-choice. So, make a contingency table given the data above. How many people do you use for the total? Because they didn't tell you how many people are in the group. So, if they do not or don't give total, use 100. That way when you say 80%, 80% means out of 100. So that means 80 out of 100. That makes your numbers a little easier. So this means that we can say that married, there's 80. So that means not married, there's 20. Okay. Then it says the percentage of the married women are pro-choice. So 30% of that 80, 30% of the 80 are pro-choice. When you multiply that, you get 24. And that's your pro-choice. So that means that you would do 80 minus 24. That gives you 56. And that would be your pro-life. Okay. Then we can come down. And it says 75% of your single, which is you're not married, are pro-choice. So 75% of 20 is 15. This is pro-choice. And then there were only 20 of those, so 20 minus 15 gives you 5 that are pro-life. All right. So we like to stick with things that are yeses and nos. Okay. So we're going to say married. We're going to put yes, no. Okay. Then we're going to do pro-choice. Yes, no. And there's a total here, and then there's a total here. All right, so there's 80 total married, 20 not married. 24 of your married are pro-choice. 56 are not pro-choice. Those not married, 15% are pro-choice. 15 are pro-choice and 5 are not. So this is 39 that are pro-choice, and this is 61. Okay, now, what's the probability that she is married? Okay, so we look at our chart here, and our married is 80 out of 100, which is 0.80, which is 80%. Probability she is pro-choice. So let's use a different color. That's 39 out of 100, which is 0.39, which is 39%. Married and pro-choice. Married and pro-choice. So that's 24 out of 100, which is 0.24, which is 24%. Okay, so married and pro-choice, let's do this one. So we have to do married plus pro-choice minus the overlap of married and pro-choice. So we have these numbers here. Married is 80 out of 100. Pro-choice is 39 out of 100. Minus the overlap of 24 out of 100. So that means 95% of our surveyed people are either married or pro-choice, because you have to do your 80 here and your 39, and then you got to take out this 24 because they're counted in both. Given that she's married, okay, given that she's married, she's pro-choice. Okay, so here we're going to do pro-choice and married over married. Pro-choice and married is 24. Married is 80. 24 over 80 is 0.30, which is 30%. Okay, last one. Okay, last one. Given that she's pro-choice, probability that she's married. So we're going to do married and pro-choice over pro-choice. So married and pro-choice is 24. Pro-choice is 39. That's going to be 0.62, which is 62%. Okay? Easy peasy. As long as you can read the charts, you're good to go. But if you have any questions, please feel free to reach out. Thanks, guys. Have a good day.